Okay, the last homologous series we are looking at is your carboxylic acids. And this one will react with your alcohols to give you esters as well. Okay, so carboxylic acid has this general formula Cn-1, H2n-1, COOH. So please remember the functional group carboxyl, which is C double bond O, single bond OH over here. Don't merge it into the formula, otherwise it will be very confusing. Okay, it has similar chemical properties, will undergo almost the same type of chemical reaction, and it has gradual change in physical properties. So your methanoic acid, 1 carbon, C double bond O, single bond OH. And then your carbon can form 4 bonds, 4 lines coming out, there must be a H. Okay, ethanoic acid, make sure you draw it correctly, propanoic acid and butanoic acid and so on and so forth. All these, because they are acids, the state symbol aqueous. Okay, so isomers. Draw all the isomers. Draw all the isomers of pentanoic acid. So we have pent. This is pentanoic acid, even though it's C4, but it's actually 5 carbon, yeah, be careful. Okay, so 5 carbon in your straight chain. 1, 2, 3, 4, 5. This is your regular pentanoic acid. And because the chain is very long, you can have a branch. Now my branch is on carbon 1, carbon 2, carbon 3. Carbon 3, you can have a branch. Carbon 2, you can also have a branch. Right, so my branch is on carbon 2, okay, or you can have a dimethyl branch on your carbon 2. So I have 1 methyl here and 1 methyl here. Okay, and then pentanoic acid will give you isomers with different functional group. This one is your ester. So be careful about your ester. Ester is C double bond O, single bond O. This O is not going to bind to H. If it binds to H, it becomes a carboxylic acid. So this O, usually we say it binds to a R group. R group can be any number of carbon and hydrogen. Okay, so we have your esters here. Ester number 1, and then you branch, you move your esters to the second carbon. Move it to the third carbon with a branch and things like that. So you will get the different isomers of your esters. Okay, carboxylic acids, these are all weak acid. So strong acid dissociate completely in water to give H+. Carboxylic acid is weak acid, it dissociates partially in water to give you H+ and the no weight ion. Okay, so for example, you have ethanoic acid. Let me draw it out again. CH3, C double bond O, single bond OH. So there's a lot of H here in the molecule. Which H will ionize to give the H+? Not all of them, only this last H. The one that is linked to the functional group give you the H+. Okay, so because it ionizes partially, we write a reversible arrow. Okay, it will give you the H+, and then it gives you your ethanoic ion. Okay, your salt name, right, always change to ATE. So the ethanoic acid give you ethanoate. Sulfuric acid give you sulfate, name end with ATE. So all the carboxylic acids, the weak acid, they have sour taste. They turn moist blue litmus paper red because they are acid. Conduct electricity in water because they ionizes to give H+ and the anions. They act as mobile charge carriers to conduct electricity. They will react with metal, carbonates, alkali and bases to give you salt. And then the hydrogen ions give the carboxylic acid their acidic properties. Okay, so let's look at these chemical reactions. These are not new reactions, yeah. You already learned it in acid-bases reaction. Okay, so first one, you have the mesh, metal plus acid give you salt and hydrogen gas. So you have metal plus the acid, ethanoic acid. Take the K, kick the H. Right, so my K should partner the CH3COO minus. So you get your potassium ethanoic. Okay, your formula is this because CH3COO minus and then you have K plus. Right, why is it whole thing minus? Is because your formula should be CH3COO H, and you know the H, this one ionized to give H plus. So when it ionizes to give H plus, the remaining one is all the minus. Okay, your H kick out give you hydrogen gas. So you get potassium ethanoic. Okay, reactions with carbonate. So chase away stupid crazy woman. Chase away stupid crazy woman. Right, so for example, you have magnesium carbonate. Get your formula correct with your propanoic acid, 3-carbon acid. Okay, so same thing, take the metal. So take the metal, magnesium, kick the H. So my magnesium still kick the last H kick out. My magnesium will partner the propanoic ion that's left behind. Okay, so it partners the C2H5COO minus and the Mg2 plus. So do the cross method, C2H5COO and then the Mg, cross method, this one bring it down, 2, whole thing bracket. Okay, so you get your magnesium propanoic, which is your salt, plus carbon dioxide plus water. Okay, when you take the magnesium, kick the H, right, the CO3, when you see CO3, always think of CO2. So there is one O, the H, one O and the H that was kicked out from H2O. Okay, carboxylic acids can also react with alkali and bases. So remember what is a base. Base is your metal oxide. Hydroxide is very important. Okay, so lithium hydroxide, because this is group 1, is an alkali and ethanoic acid. Okay, so take the metal lithium, kick the H plus. So my lithium partner the CH3COO, you get lithium ethanoic. Check your formula, Li is plus, COO is minus, your formula is correct. Okay, the H that is kicked out, partner the OH to form H2O. Alkali plus acid give you salt and water. Okay, reaction with calcium oxide, metal oxide is a base. You have to know this. Okay, metal oxide is a base plus your metanoic acid. So same thing, take your calcium, kick the H. Your calcium partner the HCOO minus. Right, so you have CaHCOO bracket 2. Why is the formula like that? It's because HCOO minus and Ca2 plus. Do the cross method. Bring down the formula, bring this 2 down. After you bring it down, bracket 2. This one, bring it down, no need to write. So you can have your calcium metanoate. Okay, and then what is kicked out? You have H kicked out, you have O left behind. H and O, don't care how many form H2O. Okay, then balance out your equation with a 2 here, put a 2 in front, and then it will all balance out. Okay, so the 4 reactions that we have learned, your base plus acid, alkali plus acid, carbonate plus acid, and metal plus acid reactions. will apply to your carboxylic acid as well. Okay, so the last reaction that you are looking at is your esterification. Basically just means forming esters. Okay, esters are sweet smelling products. Okay, so they are sweet smelling properties. They are used in perfumes and food flavoring. Okay, so when you have an ester, when or how is esters formed? Esters are formed when you have a carboxylic acid plus alcohol. It will give you ester plus water. Okay, so using this example, you have your ethanoic acid. Let's draw it up. Plus your propanol. So propanol got 3 carbon. Okay, so this one in a reaction, right? It is a dehydration reaction. Okay, why is it a dehydration reaction? The important thing is here. The OH from your carboxyl group and the H from your hydroxyl group will be lost in a dehydration reaction. Okay, so repeat here. Your carboxylic acid will lose the OH. Your alcohol will lose the H. Okay, so when it loses the H, this bond over here will go and join directly to the remaining bond here. Okay, so you will form an ester with a formula that looks like this. I am just joining everything up, yeah? This CH3 is this CH3. C double bond O is this C double bond O. CH3, CH2, CH2, CH3, CH2, CH2. Right? So I'm just joining this carbon, this bond all the way to the O. Right? So this is your ester. Okay, this ester is called ethyl propanoate. Okay, how do you know it is called ethyl propanoate? Is when we name esters. Okay, over here, to name an ester, the alcohol will end with, alcohol part will end with YL. And the carboxylic acid part will give you the salt, so it will end with the ATE. Okay, so looking at this two, right? This one is my alcohol. Okay, sorry, this is not ethyl propanoate. Okay, so to name your esters, right? This one is your alcohol. Okay, so your alcohol is propanol. Propyl, and then the carboxylic acid end with ATE. So this is your ethanoic. Okay, so this one is your propyl ethanoic. Okay, and remember the parts that were highlighted in yellow, the OH from your carboxyl, the H from your hydroxyl, dehydrate to form H2O. Okay, so since this is a dehydration reaction, your catalyst must be your concentrated sulfuric acid. Okay, so in this example, right, you have your propanol and your ethanoic acid. The OH is removed from carboxylic, H is removed from alcohol. Write your conditions on the arrow, and esterification is a reversible reaction. Okay, so you remove this, you join both of them up together. So you have your C joined to O, join immediately, and your water is formed as your byproduct. Okay, so likewise, this one will be known as propyl, because the alcohol should end with YL, and the carboxylic acid will give the salt, the ATE, propyl ethanoate. Apart from forming esters, what other reactions do your carboxylic acid undergo And apart from your metal acid, carbonic acid, acid-base acid reactions, it also undergoes combustion. So combustion, carboxylic acid burn in excess oxygen give you CO2 and H2O only. This is your standard understanding, right? Combustion give you CO2 and H2O. Okay, and then how do we form ethanoic acid? This one is formed by using oxidation reaction of atmospheric oxygen from alcohol. Atmospheric oxygen from alcohol, leave it to stand, it will turn sour. Or use your acidified KMnO4 or K2Cr2O7. Okay, when you write your oxidizing agent, put the square bracket O. Okay, and then this one will give you your water as the byproducts. Okay, ethanoic acid has these following properties or these following uses. Yeah, it's used to preserve vegetables, cucumbers, etc. This is a sour flavoring. It's used to make drugs, used to make dyes, used to make paints, insecticide, plastics. Basically, this one is to tell you there's a lot of use for ethanoic acid. That's why we are studying it.